Hey guys, welcome to another video of your favorite cloud learning platform, K21 Academy, where you learn cloud from the experts. Let's have a look at the agenda of this video. First, we will be covering what is a load balancer. Moving on, we will be covering how does a load balancer works. And to finish it off, we will be looking at in depth about the different types of load balancers. We will also be discussing about the advantages and disadvantages of each type of load balancer. We have taken this clip from our step-by-step learning program on AWS Certified Solutions Architect Associate. Now, let's hear from our expert.
So what does a load balancer means is actually does what it distributes. It distributes and manages the incoming traffic load among several devices to improve the performance. Whether it is a server performance or it is a network performance, it helps to improve the performance. So what happens here, that suppose say you have got these client users sitting over here, they are hitting on to the application servers. In general scenario, if we consider that I have only one web server in place, so what will happen, the requests will directly hit on to the web server number 1 in the scenario where I have only one application server or web server working for me. But in corporate, it does not works like this, because in corporates, we always thinks about the high availability of the machine. We always think about the high availability of the machine. So what we have to do over here is, we in the corporates, what happens that you will be doing what, you will be actually launching two web servers of the same type, and then it can happen in such a way that either you can make it work like that, this is your primary server. As long as the primary server is up, the requests will be served by this server, and if it goes down, the requests will start moving on to the secondary server. It will start moving on to the secondary server if the primary goes down. As soon as the primary comes up again, the requests will start moving towards the primary server again. So this is one way in which we can achieve this particular high availability. Another way to achieve the same is, instead of doing it primary secondary, I can have it as a active cluster. Active cluster. So in active cluster, it happens in this way that some of the requests are entertained by the web server 1 and some of the requests are entertained by web server 2. So now there should be a system sitting in between who should decide that what some of the requests will go on to this server and which will be the requests which will go to the other server. So this particular appliance which sits in between is known as a load balancer. Load balancer will balance the load which is coming from the outside users. It will be landing up on the load balancer, and then the load balancer will have a target group here. It will have a target group. So then the load balancer will distribute the load of these users to the machines who belongs to the target. And that policy, how the load will be distributed, will be defined by this load balancer machine. So in Amazon, when we create a load balancer, we have got two kinds of routing policies working for us. One is round robin policy. That round robin policy means what? One request will go to this server, other will go to this server. Second, again this, again this, again this, again this. So this is the one type of policy that we have, which is known as round robin policy. Another policy, routing policy, that is available in the load balancers of Amazon is the server with the least load will be given the fresh request. So if this particular server is already entertaining 5 requests and this server is replying and working on 3 requests, the other request, the 9th request that will come will go on to the server number 2. So the server with the least number of requests the request will be shared onto that server. So these are the two kinds of routing policies that I can configure on the load balancers which are provided to us by Amazon. It helps us to improve the performance of the web server or the application server that is working behind the load balancer. So this is what the load balancer is. Amazon gives you 4 different types of load balancers. One is application load balancer, second is network load balancer, third is gateway load balancer, and fourth one is classic load balancer. This classic load balancer is the oldest load balancer which was there, which was having limited functionalities and was the only load balancer service provided by Amazon, and it was a bundled service, like every service was provided on this particular load balancer only. Later, Amazon has segregated the types of load balancers into 1, 2, and 3. That is application load balancer, network load balancer, and gateway load balancer. So these are the 3 types of load balancers which are latest onto the portal of Amazon. This is going to get decommissioned soon. So these are the 3 types of load balancers that one has to focus upon. If we talk about the classic load balancers, the classic load balancers are the load balancers which balances the traffic across multiple instances in multiple availability zones. So in this, how does it happens? Like with the classic load balancer, the functionality that we were actually having was that it was supporting the EC2 classics. That means you can launch a EC2 machine out of VPC. That is a feature which is provided by Amazon. So this classic load balancer supports that particular EC2 instances. Also, rest 3 load balancers do not support the EC2 classic. Normal EC2 also it supports the EC2 classic also. So with classic load balancer, it increases the availability of your application by sending the traffic to the healthy instances. So what happens that in classic load balancer also, what happens over here is you add the instances into the load balancer. You add the instances. You do not have a target group or anything in classic load balancer. You directly add the instances into the load balancer. So whatever traffic comes onto the load balancer is distributed on these machines. And then this load balancer sits here. It keeps checking the health of the machines. So what we have to do is, while creating the load balancer, I need to tell which parameter to be checked to check the health of the machines. So suppose say the parameter that I mentioned is that go and check port number 80 on the server IPs. If port number 80 is responding properly, that means my server is up and running and keep sending the traffic. If my application is running on port number 80, so then I will say to check it for the port number 80. So if that particular port number on this server is responding properly, that means my server is up and running. So it will keep sending the request to the healthy servers. If at certain point, suppose say this particular server stops responding to port number 80. So what the load balancer will do, it will declare this particular server as unhealthy, and then the request will be sent only to the healthy servers. It will stop sending the request to this unhealthy server, and at the back end it will keep checking, are you healthy again? Is everything fine with you? Is everything fine with you? It will keep on checking. So once the server comes back and says, yes boss, now I am okay, I can take up your request, it will add it again back to the load balancer, and the request will be start getting distributed to this 4th machine also. So this is the meaning of healthy instances. So it increases the availability of your application by sending the traffic to the healthy instance, and this is common to all type of load balancers, whether it is classic, application, network, or gateway. It's common to all type of load balancers, this particular check. The classic load balancer supports HTTP kind of traffic, HTTPS kind of traffic, TCP, and SSL listeners. These were the four types of ports which classic load balancer was supporting for balancing the traffic. And then it also supported sticky sessions, which is also there in other type of load balancers also. So what do we understand by the sticky session? Just imagine a scenario of a banking application. You as a user, so these application servers are at the backend talking to the database server. As soon as you as a user hits the website, clicks on the login, and your request went to server number 1, server number 1 will do a authentication process in which you will be asked to write your username and password. So if this authentication process is successful on server 1, then any further requests which are coming from this particular user will be entertained by this server. If you have enabled the load balancing, what will happen that probably first time when you clicked on login, you went to server number 1, your username password was entered, you were authenticated and logged into your application, ICICI bank application, you are logged in over there. Next time you clicked on generate the statement, account statement, and then unfortunately the request went on the server number 4. So this server will think that you are not an authenticated user. It will again prompt you to enter the username and password. Once you enter the username and the password, then you will be able to access the statement. Otherwise not. After that, you try to do a transaction, and while doing the transaction, the load balancer throwed you on server number 2. Again, you were prompted to enter the username and the password because according to server number 2, you are not an authenticated person. So this is an issue. To solve it, what I should have, that if I am authenticated once as a user, I should remain with server number 1 for certain time duration, maybe for 5 minutes. That my request should always go to server number 1. It should not go to any other server. You must have seen some kind of session timeout, that your account is going to log out in this much time. You get a prompt on your banking screen that you need to complete the transaction in this much time. Your account is going to log out. Why log out? Because there is a feature called session stickiness, which can be enabled on the load balancer, which helps you to stick to this particular server for 5 minutes. And if within those 5 minutes period of time, if you are coming on to the server, you will be actually routed to the same server every time. So there are multiple timeouts. There is one is TCP timeout, one is session timeout. Okay, one is this load balancer timeout. So multiple timeouts are working in the background. So I'm just giving you a example to understand it. While you are doing the transaction, and if this server goes down, this load balancer will understand that the load balancer, the server is gone down, and it will route you to the second server. There you will be re-authenticated. Your session will be terminated and you'll be re-authenticated to further access any services on your account. You must have experienced sometimes that, oops, something went wrong, the transaction was not completed. So probably that was the case when you were working. Fine. So this is actually the basic features which works with the load balancer. So your classic load balancer was also supporting the session stickiness. So you can enable the session stickiness on your load balancer. With classic load balancer, you have got certain limitations, that the load balancers per region that can be created is maximum 20 load balancers can be created, and you can have listener ports up to 50 maximum. Security groups that can be attached to the load balancer at maximum is 5. Now this particular limit of security groups has been revised to 8 security groups, with the machines also and with the load balancers also. So you can associate up to 8 security groups to a single load balancer. The number of registered instances into the load balancer can be maximum up to 1000, not more than that. And then subnets per availability zone can be 1. Now this is a bit confusing. Anyways, when you have a VPC and you have got 6 availability zones, you get 6 subnets. Subnet 1, subnet 2, subnet 3, subnet 4. Then what is the meaning of this? You'll understand this when you will learn to create the custom VPCs. Because when you create the custom VPCs and your custom subnets, so your subnet 1 and subnet 2 probably belong to the same physical availability zone. So this is the limitation. Okay, this is the limitation. In this limitation, it says that one subnet per availability zone is only supported in the load balancer, the classic load balancers. If you want to have 2 subnets, don't create it in the same availability zone if you want to use them in the load balancer. Create subnet 1 in availability zone 1 and subnet 2 in availability zone 2, the physical availability zones of Amazon. So then you will understand it in a better way. The other type of load balancer that we have is network load balancer. So when we say network load balancer, I have explained you something, I believe on day 1 or something, that there is a OSI model. There is a model, Open System Interconnect model, which has got 7 layers. It has got 7 layers. These 7 layers are actually defining the various activities that happens on the network while your data is transferred from one machine to another machine. So these 7 layers, if we talk about them, 3, 4, 5, 6 and 7. So these 7 layers are numbered like this. This is layer 1, layer 2, layer 3, layer 4, layer 5, layer 6 and layer 7. So the 7th layer is your application layer. The 6th layer is your presentation layer. I'll help you to understand the layers also. The 5th layer is your session layer. The 4th one is your transport layer. The 3rd layer is your network layer. The 2nd is your data link layer. And the last one, the 1st layer, is actually your physical layer. So if we talk about the functionalities of this layer, this 7th layer is actually the Ethernet cables that are connected to the machines, the RJ45, the fiber cables which are connected to the machines, they works on this particular physical layer. The IP addresses that we are talking about, that machine got an IP address, machine got an IP address. So that IP address works on your 3rd layer. The visibility, whether the service that you are using is a TCP service or it's a UDP service. Which type of service are you using? This visibility comes on your transport layer. And on application layer, you get the visibility about the port numbers. That now, like, there are services which are available in the network. So suppose if we talk about this particular service of port number 80, it falls under the category of TCP. It falls under the category of TCP. So now there are multiple services which falls under this category of TCP. The SSH 22 also falls under the category of TCP. So now out of these TCP group, out of these TCP groups, which particular service are we talking about? This visibility comes on the layer 7. So these are the different layers. So there is a lot of theory, like I can sit with you for 4 to 5 hours to explain you about 7 layers. But then for us, it is more than enough to understand that when we talk about the MAC address, it is my 2nd layer. When we talk about the cables, it is my 1st layer. When I talk about the IP address, this is my 3rd layer. When I talk about the TCP and UDP, it is my layer number 4, that is transport layer. And when I talk about the visibility about the port number, specifically which service, so then it is my application layer which gives me that visibility. Okay, so the network load balancer that we are talking about, it performs the load balancing based on the layer 4 visibility. That means whether your traffic is TCP or your traffic is UDP kind of traffic. So that it provides the load balancing by studying this particular category. So this is a load balancer who performs the load balancing based on the visibility that you get via the layer 4. It supports the TCP protocol and can handle million requests per second. This is what your network load balancer is. The network load balancer handles the sudden and violate traffic across EC2 instances in order to avoid the latency. But then he can distribute the traffic based on the TCP protocol only. The limitation here again, it can have only 20 load balancers per region. And then, as I have told you, that the advanced levels of load balancers work with the target group. So I have a target group. So whenever the load balancer gets a request on X port, it forwards the traffic to the target group 1, and the target group 1 has got 3 machines on which the traffic will be distributed. If the load balancer receives the traffic on port number Y, it will be forwarded to the target group 2, which has got another set of machines which are there in the target groups. So I can have a virtualization of the load balancer happening if I'm using the advanced level of load balancers with Amazon. The advanced level of load balancers are your network load balancer, your application load balancer, and your gateway load balancer. The classic load balancer do not support this particular feature of target groups. So the limitation is that you can have up to 3000 target groups that can be created per region if you are using network load balancer. This is the limit. Number of listener ports, again, it's 50 at the maximum. Targets per availability zone, it's 200. Target with cross zone load balancing enabled, again 200. And then subnets per availability zone is still 1. You can have 1 subnet per availability zone for your custom VPCs, even with the network load balancer. The third type of load balancer which is offered by Amazon is application load balancer. With application load balancer, which is also known as ALB, you have a visibility of the things which works on layer 7. So that means you will be able to distribute the traffic based on the port numbers. It supports 2 kinds of WebSockets, which is HTTP and HTTPS. That's it. The application load balancer, it supports only HTTP and HTTPS. So it even supports the microservices and container-based application, including the deep integration with the Amazon Container Service. So if you want to use the container service in Amazon and want to perform the load balancing, application load balancer is going to help you with that. So it can help you on the microservice level. So microservice means what? Now the every website is accessed on port number 80, but on or 443, every web service. But then on this, let me give you an example in an easier way. You have got social media application, Facebook. In Facebook, the company wants that you should be able to access the Facebook wall, but you should not be able to access the messenger. Okay, so this is called control till microservice level. So Amazon with application load balancer can support load balancing based on the microservice levels, this particular application load balancer. Again, limitation says only 20 application load balancers per region, target groups up to 3000, listener ports only up to 50, targets 1000, subnets per availability zone is still 1, security group is 8, rules, I'll show you where the rules can be created. It can be up to 100 rules which can be created. If you want to enable HTTPS certificate attachment, 25 certificates can be attached. Number of the times the target can be registered is 100 times. A target that you create is registered to the target group. If in case something happens, it will get deregistered. If some problem happens, it will get deregistered. Then again it will get registered, again it will get deregistered, registered, deregistered. Maximum up to 100 times it can be registered and deregistered. Okay, so the number of times a target can be registered in a load balancer is the 100. More than that, then you have to do some extra process for it. So these are the different types of load balancers that we have. One more we have gateway load balancer. So why do we use the load balancer? The benefits are better performance, supports monitoring by health check, supports registering the targets via the IP, which IP has to be registered. It also support host based routing. It support path based routing. As I have told you, if the host is having less load, send the traffic to him. If the host is then it is one is round robin method, and it supports multiple application hosted on a single EC2 instance, because every application which is hosted on a EC2 instance will run on a different port number, So now in the application load balancer with different port numbers, you can have different target groups. And the beauty is that the machine which belongs to target group 1 can even belong to target group 2. So you can share the machines between the target group. There is a server. So on this server, on port number 80, my application 1 is running, web server is running. And then on port number 3000, I have a Node.js application which is running. So I can create two target groups for it, although not with application load balancer, because with application load balancer, I can only have HTTP and HTTPS. So I have 3000. So I can create a target group 2, and this same server can be part of target group 1 also, and can be part of target group 2 also. So if the user hits with port number 80, the web server will respond. If the user hits on port number 3000, the Node.js application will respond. So it works like this. So this is the benefit that we get. The fourth type of load balancer that you have is gateway load balancer. This is specifically used when you want to deploy, scale, or manage your third-party virtual appliances. Suppose say you have got a firewall of Palo Alto or Fortinet or Cisco or Checkpoint, any company firewall. You have a virtual appliance implementation for the firewall in the cloud. You have got firewall 1 and firewall 2 for high availability. If this goes down, this is still protecting your network. So if you want to have that, you want to balance your traffic to both the firewalls. In such scenarios, you need to use the gateway load balancer. Understood? Because it scales your virtual appliance instances automatically if there is more load coming on the firewalls. This helps you to do that. And it also helps you to monitor the health and the performance metrics of your third-party virtual appliances. This also have a limitation that it runs within one availability zone, but then it gives you a feature to do the implementation for the third-party appliances. Firewall is one of the example. You may think about other, maybe probably you are using server load balancing, and third-party application you are using Golden Gate for database application, and you want to have a third-party virtual appliance implemented with load balancing. So in such scenarios, gateway load balancer has to be integrated with the scenarios. And then same 20 load balancers per region. And load balancer components. So the gateway load balancers per VPC can be up to 10 only. Per VPC only up to 10. Target groups up to 100. Target groups per availability zone, it's up to 300. This is the difference between the target groups with Genevieve protocol and target groups per availability zone per target group with Genevieve protocol. So this is per target group, you can have 300 targets that can be registered inside a target group. So you can have 100 target groups, and inside one target group, you can have 100 targets that can be connected. So these are the 4 different types of load balancers that we have.
We hope that you liked the video. We have put on everything about the certification, including the basic concepts that you should be knowing about on this 8-week learning path for AWS Certified Solutions Architect, where we start from the very basics like introduction to cloud. We move on to create cloud account, machine and install CLI. Then we do security management AWS. Then we cover object storage options. After that, we move on to designing computing environment. After that, we cover load balancer, route 53 and auto scaling 1. And then load balancer, route 53 and auto scaling 2. After that, we cover networking and monitoring services. We follow on with database, server and analytics. We next cover application and messaging services. We move on with configuration management and automation. After that, we cover architecting on AWS 1 and then architecting on AWS 2. To cover it up, we help you with your certification with tips and resources for clearing certification, then CV preparation, and then we also guide you through how to register for exam and prepare for the certification exam of AWS Certified Solutions Architect Associate. And after that, we help you with some sample questions and projects for Solutions Architect exam. We have a separate team for CV preparation and on-job support. So if you want to learn from basic to expert level, then we have a comprehensive step-by-step training for you that includes hands-on labs and exam prep and 1 year on-job support. If you are interested in this program, then I would highly recommend you to join our free class. This interactive session or free class will help you in gaining an understanding of why and who should learn AWS Cloud, job opportunities in AWS Cloud, core AWS services, IAM, compute, storage, networking, HA and DR architecture, and many more. There's also going to be a live demo in which we will demonstrate how to create and configure load balancer with EC2. And for all the people who will be joining in, there's going to be a special gift. You're going to get a 25 sample exam questions for AWS Solutions Architect as a free bonus when you will be attending this free class till the very end. So to register this free class, go at K21Academy.com/AWS SA02. Now I'll be demonstrating how you will register for this free class. You can register for this webinar or any of the browsers out there. You just need to search K21 Academy AWS SA02 and click enter. Once you do that, you will be redirected to this web page for the registration of this free class cum webinar. Click on register now. First, select the event date that you want to attend it on. Then enter your name and your email ID. After that, enter your phone number. Click on yes, save my seat. Once you click on that, you will be redirected to this particular page. This means that you are indeed successfully registered for the webinar. Make sure you are redirected to this page because then only you will be registered for the webinar. You can have a look at what you'll be learning in this webinar here as well.